Good morning everyone. In this session we are discussing AES algorithm. Previously we discussed SAS algorithm. Okay. AES algorithm. Aim of this is introduce AES algorithm and its principles. This section is designed to define the AES algorithm, to explain the principles of the AES algorithm, to write code to encrypt decrypt data using AES algorithm. At the end of the session, we should be able to explain the purpose of AES algorithm, identify the key components of the AES algorithm, describe the steps involved in encrypt decrypting data using AES algorithm, write code to encrypt decrypt data using AES algorithm. These are the learning outcomes. What we are discussing in this session, we are discussing AES algorithm, overview of AES algorithm, AES representations, AES encryption, AES description, advanced disadvantages of AES. AES algorithm, input is 128 plain text black, 128 bit key. Output is 128 ciphertext black. Steps: add round key, the plain text block is XORed with the first round key. Sub bytes, each byte in the plain text is substituted with a new byte using S box. Shift rows, the rows of the plain text block are shifted by different amounts. So mix columns, the columns of the plain text block are multiplied by matrix. Repeats 2 to 4 for 9 rounds. For 10th round, we are applying only three operations. Sub bytes, each byte in the plain text block is substituted with a new byte using S box. The rows of the plain text block are shifted by different amounts. The plain text block is XORed with the final round key. Output is ciphertext black. The overview of the AES algorithm. Block size is 128 bit plain text. Number of rounds are 10. Key size is 128 bit. Number of subkeys are 44 subkeys. Each subkey size 32 bit. Each round 4 subkeys. Pre-round calculation 4 subkeys. Ciphertext 128 bit. So this is AES encryption. Already we discussed SEAS. The similar way, 16 bytes plain text, 128 bits. Add round key. So add round is containing W0, W1, W3, 4 bytes. Okay, 4 into 4 means 16 bytes. So this applied to the add round key. We are getting the output of add round key is applied to substitute bytes. That is the output of substitute bytes is applied to the shift rows. The output of shift rows is applied to mixed columns. Mixed columns is applied to add round key. This is out round 1. In the similar we are applying 10 rounds, but the 10th round mixed columns is missing. We are not applying mixed column operation. Okay, we are not applying mixed column. So these are AE representation. Input is stored at array 4 by 4 table, 16 bytes, 16 into 8, 128 bit. Input 0, input 1 like this. Total 16 bytes. Input is stored in input array. We can write as input array. Okay. Intermediate results. Intermediate results stored in state array S00, S10, S20, S30 like this. State array. Okay. S01, S11, S21, S31 like this. So AES output is stored in output array 4 by 4 output 0 output 1 like this. Up to output 15, 16 bytes. By giving 16 bytes of input, are getting 16 bytes output. So this is key. Key also divided here of 128 bit key is 4 by 4 expanded to W to 0, W0 to W1. So total 44 keys is expanded to 44 sub keys, where 40 words are used for 10 rounds, remaining 4 is used for free addition. So these keys are expanded to W0 to W43. These are in those expanded keys, sub keys. 40 words are used for 10 rounds, remaining 4 is used for free addition. Substitution bytes, already we discussed 4 operations. In this step, each byte is substituted by another byte. It's performed by lookup table is called X box. By using X box, substituted byte should be performed. This operation is performed. The substitution byte is indicated that a byte is never substituted by itself and also substituted by another byte, which is a complement of the current byte. Okay. So shift rows. Shift rows, each row is shifted a particular number of times. First row is not shifted, always same. So B0, B1, B2, B3, the first row is never shifted. The second row is shifted once to the left. The third row is shifted twice to the left. The fourth row is shifted twice to the left, like this. Okay. Mixed columns the same. The step is basically matrix multiplication. Each column is multiplied with a specific matrix, and the position of each byte in the column is changed as a result. This step is skipped in the last round. C0, C1, C2, C3 like this. Okay. Add round keys. Now the result output of the previous page is XORed with the corresponding round key. Here 16 bytes is not considered as a grid, but just as 128 bits of data. After 10 rounds, 128 bits of the encrypted data is given as output. This process is repeated until all the data to be encrypted undergoes this process. Here is description. This is changes in the this is description keys. Add round key same. Inverse mixed columns. Shift rows inverse sub byte. So there are mixed columns in the encryption, here inverse mixed columns. So shift rows is same, add round key is same, but inverse sub byte. Okay, inverse mixed columns is like this. We are using B0, 14, 11, 13, 9, 9, 14, this is the matrix. 11 here, 11, 13, 13, 9, 14, 11, 11, 13, 9, 14, like this. Inverse sub bytes. Inverse S box is used as a lookup table and using which using the which the bytes are substituted during decryption. The advantages of AES, it is very secure, it is efficient and fast, it is widely supported. Disadvantage, it is symmetric algorithm, which means that the key must be shared between sender and receiver. It is a black cipher, which means that data can be encrypted, that it can only encrypt data that is a multiple of the block size. There is also one disadvantages. This is the summary. So AES algorithm is a very secure algorithm. It has been shown to be resistant to a variety of attacks, including brute force attacks and differential cryptanalysis attacks. The AES algorithm is the most widely used black cipher in the world, used to protect data in a variety of applications, including electronic commerce, wireless applications, and storage devices. These are the self-assessment questions. The AES algorithm is symmetric key, which means that the same key can be used for both encrypting and decrypting the data. One key is used for encrypting, another is used for decrypting the data. The answer is both A and B. Which are the following is the correct order of steps in the AES algorithm? There should be sub byte, shift rows, add round key, and mixed columns. There are the self-assessment questions. You may guess the answer. What is the black size of AES algorithm? So we have discussed how many rounds that the AES algorithm we have? Already 10 we have. These are the terminal questions. What is the purpose of the AES algorithm? What are the key components of the AES algorithm? What are the steps involved in encrypting and decrypting data with the AES algorithm? How does AES algorithm compare to other black ciphers? What are the advantages of AES algorithm? These are the reference books. Thank you.